This will be our project 2 in this natural language processing playlist. We have already made movie recommendation system. That is our project 1. There are a lot of projects to come. Let me talk about the project that we will be discussing in this video. That is, next word prediction. By its name, I hope you already know what this project is about. In many platforms like YouTube, Google, and so many other, when we type something, automatically some suggestion appears, right? Suppose when I type natural language in Google, automatically list of suggestions appear. How is this possible? This is because this all are the searches that human have made before. And these data are stored by Google, maybe in cache file, either in client side or server side, right? Using that data, it is able to suggest next word. In this project, we will use one text file, and using that text file, we will create our model, and using that model, we will predict next word from the previous 3 words. Yes, I will be using 3 words to predict next word. First of all, you have to download text file. There is no restriction to download specific text file, you can download anything. I am using text file from this site. I will paste this link in the description below. If you want to use same text file, you can download same file also. I am downloading Pride and Prejudice text file. Rename this file and then save. This is my file. Now, it's showtime. I am using Google Colab to execute my code. In my Project 1 video, I have already explained, how can you use Google Colab if you are not familiar with this platform. This project needs high processing power, so I am using Google Colab. You can also use this. You can change the runtime from here. Just select GPU and click on Save. First step is to load required libraries. I hope you are familiar with these libraries. If not, I will explain all these at the time when I use this package. Next, I have to make my text file available here. I have downloaded Pride and Prejudice text file. Let me execute this cell. I have to choose same file. Now I can use my text file in this Colab. And if you are executing this code in your local system, you don't need to execute this cell. You have to keep your file in the folder where your Python file is located. Next, I have to load and pre-process my data. First, open the file in read mode. Then store the file in list. That is, iterate each line of the file and store in the list. Next, convert list to string. For this, we can use join function of Python. Next, replace unnecessary symbol with spaces. Like replace new line with spaces, carriage return with spaces, Unicode character with spaces, and also opening and closing double quotes with spaces. You can copy opening and closing double quotes from the text file. In my text file, I have lot of opening and closing double quotes. If you want to keep double quotes, you can also do that. There is no any restriction. Next, I have to remove unnecessary spaces from my data. For this I have to split my text and store in list and then convert list to string. Finally, let me print few data. This is my pre-processed data. On the basis of your text file, you can apply more pre-processing on your file. I have already discussed several pre-processing steps in my previous videos. I can also check the length of my data. Next, I have to apply tokenization in my data. This time I am not using NLTK. I have imported tokenizer from Keras. I can easily convert text to sequence and sequence to text with this package. First, I have to create an object of tokenizer, then pass my pre-processed data. Next, I can save my tokenizer file using pickle with name token.pkl. You all know, we have to convert our string or text into some numeric representation. This texts to sequences from tokenizer do the same. Then I am printing first 15 sequence data. My text is successfully converted into sequences. I can print the length of sequence data. This length will be less than the length of my data. Because in my text file, there are so many words that are repeated. Each unique word gets one numeric representation. And also, it filters out any punctuation and white space. Then my vocab size will be word index +1. Because index 0 will be reserved for padding. I can print my vocab size. It's only 7036. So, we have 7036 unique words in our text corpus. Now, this step is very important. I have one empty list. Then I have iterated over my sequence data. I have already mentioned that I will use 3 words to predict next word, right? I am doing the same. I am inserting 4 words in my list, out of which 3 words will be my input and last word will be my output. Suppose when I equals 3, then slicing will be from 0 to 3, last index is not included. When I equals 4, slicing will be from 1 to 4. Like this. And I am appending each 4 words ID in my list. I will show you the output, don't worry if you didn't get it. Let me print the length of my new list. I have to convert my list into array. And then let me print first 10 sequences. This is the length of my sequences list. And this is my required sequences. In each line, I have 4 words ID. This 3 will be my input and this will be my output. Same as other also. Using these 3 words, I have to predict next word. Now, let me separate my input and output. That is, my dependent and independent variable. I have 2 empty lists. I will append first 3 words ID in X variable and last word ID in Y variable. Let me convert them to array. Let's print top 10 data and response. You can see, my first 3 words ID will be in my data list. And last word will be in my response list. You can check by yourself. Next, we have to convert our class vectors into some binary class matrix. Later, we will use loss function as categorical cross entropy. And this requires your integer value to be converted into binary matrix representation. Now, let's create our model. I am using sequential for creating my deep learning models. Then, I am creating embedding layer which takes 3 arguments. First is the input dimension, which is the size of vocabulary in my text data. Second argument is output dimension, which is the size of vector space in which words will be embedded. I have passed output dimension as 10. This means, the size of word vector for each word will be 10. Third argument is input length. I will use 3 words to predict next word. So, I am passing input length as 3. Then, I am creating LSTM layer in which first parameter is the number of units, that is, the dimensionality of the output space. And second, return sequences equals true indicates I am creating next LSTM layer. So just return the last output. This is the second LSTM layer. I am not passing return sequences equals true because I am not creating another LSTM layer, right? Next, I am creating dense layer which takes units and activation function as arguments. I am passing activation functions as RealU, which converts negative value to 0 and do nothing with positive value. I am creating another dense layer. This time, number of units will be my vocab size. Because I want my output within this vocabulary. And I am passing activation function as softmax, which scales numbers into probabilities. This is how we have to define neural network. That is, this is how we can create our model. Let me print the summary of my model. It displays all the format that we have defined while creating our model. That is, it displays input dimension, output dimension, our layer name and number of parameters. You can visualize this by yourself. I can also plot my model. These all are optional. This is only to get visual look out of how our model looks like. Next, build our model. That is, we have to train our model. I am importing model checkpoint, which is used to save our model and waits at some interval. I have to pass file path to save my model file. Second, I have passed monitor as loss which deals with total loss value of my model. Third, I have passed verbose equals 1. I can pass either 0 or 1 to check the training progress. Fourth, I have passed save best only as true which only save my best model. I hope you are somewhat familiar with this term. If you have any doubt, you can ask me in the comment section below. Then, I have to compile my model by passing loss and optimizer function. I am passing loss function as categorical cross entropy which is used for multi-class classification task. That is, we have several possible outputs out of which my model has to choose one. Next, I have pass atom optimizer to update the weights iteratively based on training data. That is, it is used for training deep learning models. And also, I am passing learning rate as 0.001, which indicates the amount that the weights are updated during training. Final step is to fit my model. I have to pass my dependent and independent variable. This epochs indicate the number of iterations over the entire x and y data. I have defined epochs equals 70. That means, it will iterate my entire dataset up to 70 times. Next, I have defined batch size which is the number of training samples in one forward or backward pass. The higher the batch size, more memory space we will need. If we define very big batch size, it may not fit into memory, and takes a long time to be trained. I have defined batch size as 64. That means, in each iteration, the algorithm takes the first 64 samples from the training dataset and train the network. Then the next 64 samples and again train the network. Like this. Then, I have passed callback function which I have defined earlier. Now, let me execute this cell. This step takes little bit more time. In each epoch, it will display the loss value. You can see the message. Loss value improved from this to this. There comes the case when your loss value doesn't get improved from the previous epoch. But as we have defined save best only as true, it will only save my best model. I hope you have noticed, as epoch increases, loss value get decreases. Let me fast forward this step. You can see here. Loss did not improve from this value. So, it will call back previous best model and forget this one. My execution gets completed. This is my final loss value. You can also increase the number of epochs. This is how we can build our model. And I have also saved my model, so that I don't need to build my model again and again. All I have to do is just load my model next time. Next and very important part. We have prediction. This is the required libraries for prediction. I am loading my tokenizer file and my model file that I have saved before. Let me create function with name predict next words, which takes parameter tokenizer file, my model file, and text, which will be my 3 words from which I have to predict next word. Same as before, I have to convert my text into sequences, and then convert into array. This time, my model has to predict. Because I have already trained my model, right? And this np.argmax return indices of the maximum value. Then, I have defined null string. I will iterate over each items of dictionary that are in my tokenizer file. And if any value in that dictionary matches to the pred value, assign predicted word as a key. I hope you know dictionary has key value pair. And if my pred value matches to the dictionary value, then next word will be a key of that value. Then go out of for loop. Finally print that predicted word. And return that word. If you didn't get it, you will be cleared when I show you the output. So, just give your best to understand this. Now, I have to take input from the user. I am opening infinite loop. Take input from the user. If I type 0, it will stop the execution. And if I type any word, split that word. And take last 3 words. Because I have to predict next word from 3 words, right? So, I have to focus on only last 3 words of my input. Let me print that last 3 words. Then I have to call my function. I have defined my function before. And now, I have to call that function. If any exception occurs, it will display exception message. Now, let me execute this cell. And let me open my text file. Let's see how much correct next word it will predict. It will either return exact word or similar word. Let me copy the project Gutenberg and paste it here. Our next word should be ebook, but it returns literary. That's okay. We will pass next input. If I copy the project Gutenberg ebook of and paste it here, it only considers last 3 words. That is, Gutenberg, ebook, of. Our next word should be pride, and it also returns pride. In the same way, let me copy this text. Our next word is children, and it also returns children. Next, he was quite. Output should be young. And it also returns young. Suppose if I copy only 2 words, then it will return 1 warning. That is, we have to pass at least 3 words. Let me copy this text. Now my output should be pretty. Great. You can see, this is very accurate. In the same way, if I copy this text I think this doesn't get match. But you can clearly see, most of the output are correct. Let me copy this text. Next word should be nothing. Great, it also returns nothing. And when I type 0 and hit enter, it will stop execution. This is how we can make next word prediction using LSTM. Let me recap from beginning. First of all, we have to load required libraries. Then we have to load and pre-process our data. You can pre-process on the basis of your project and your data. Then we have applied tokenization. We have converted our text to sequences. And also, we have separated dependent and independent variable. That is, our input data and response, right? Then we have created our model. We have also plotted our model. And finally, we have trained our model by passing several parameters that we have discussed before. Finally, we have made predictions. And we found our project is really working and accurate, right? You have to practice this by yourself. Believe me, this is not that much hard. I will put the link of this code in video description. I have taken so much time to make this project possible. So please guys, subscribe this channel. Like this video. I will bring such type of project again and again. I will meet you soon. Stay safe and keep learning.